Okay, let's dive right into this. When we look up at the night sky, it's so incredibly easy to just imagine our solar system as this peaceful, perfectly predictable place. Just planets spinning quietly in nice, perfect circles, right? Well, in this explainer, we're going to completely shatter that illusion. Because the truth? The universe is actually a profoundly chaotic, shockingly violent environment.
Which brings us to a seriously mind-blowing question. What if that unimaginable violence of the cosmos is literally the only reason we're alive today? What if all that planetary bullying, cosmic pinball, and just pure unpredictable chance didn't just happen to exist alongside us, but actually paved the exact way for our existence?
So here's our flight itinerary for today's explainer. First, we'll look at Jupiter's bizarre fuzzy core. Then, Earth's chaotic cosmic journey. After that, the Moon's secret habitable past. Fourth, the massive impact that actually saved Earth. And finally, we'll wrap up with the potential for alien life on Titan. Let's get going.
All right, Section 1. Jupiter's bizarre fuzzy core, or how the bully of the solar system grew up fast.
Now, what's really interesting here is we're starting our journey about 500 million miles away to look at how the absolute bully of our solar system grew up. For the longest time, the massive question driving astronomers was simply this: does Jupiter have a solid core? I mean, you'd naturally assume every planet has a solid center, kind of like Earth, right? Well, to figure this out, NASA's Juno probe couldn't just look at the clouds. It had to use gravity. As it orbited, Juno sensed these tiny gravitational spikes, essentially little speed boosts, that mapped out exactly where the mass was hidden deep, deep beneath those dark, stormy clouds.
And man, what scientists found sent them straight back to the drawing board. They totally expected to find an avocado, a dense, solid pit of metal and rock right in the center. But instead, they discovered a bowl of chili. Yeah, Jupiter has this completely amorphous, fuzzy mass where hydrogen fluid and rocky material are totally dissolved and blended together. It's a type of planetary core we had literally never seen before.
So, the crucial point we gotta ask is, how on Earth did this strange fuzzy core form?
Well, it all comes down to beating a ticking cosmic clock. Picture this. 4.5 billion years ago, our young sun was fiercely active, threatening to violently blow all the planet-building gas away within just 4 or 5 million years. Basically, Jupiter had to move fast. So instead of waiting around for massive rocks to slowly crash together, it started this wild feeding frenzy on tiny pebbles. This process, called pebble accretion, allowed Jupiter's core to gorge and grow 1,000 times faster. It hit critical mass, absorbed other early planets, and completely dissolved them into that fuzzy chili core we see today. And it did the whole shebang right before the sun could strip the gas away.
Moving on to Section 2, Earth's chaotic cosmic journey, riding a cosmic carousel.
Let's travel back to our home planet for a second. We all have this very comforting assumption that Earth is just gently floating along in a perfect, stationary circle. But actually, we are riding a wild cosmic carousel. Earth isn't just orbiting the sun, our entire solar system is hurtling around the center of the Milky Way at an astonishing 537,000 miles per hour. And it is definitely not a flat, smooth ride. Because the mass of the galaxy is uneven, we actually bob up and down through the galaxy's plane, literally like a horse on a carousel. Over the past 3.7 billion years, this incredible bobbing motion has dragged us through different galactic neighborhoods. And wandering into some of these bad cosmic neighborhoods could very well be the culprit behind massive extinction events that wiped out almost all species on Earth. Crazy, right?
You don't even have to look that far out, because there's a much more localized chaos happening right in our own backyard, and it hits like absolute clockwork every 405,000 years. Jupiter, acting like that playground bully again, and Venus, our closest neighbor, gravitationally gang up on Earth.
This gravitational tug-of-war actively stretches Earth's orbit into a severe ellipse, and it acts as this massive cosmic butterfly effect. When our orbit elongates like that, our climate goes to absolute extremes. Hot weather becomes severely hotter, and cold weather becomes devastatingly colder. These exact orbital shifts are what trigger massive ice ages. I mean, just 18,000 years ago, this cycle plunged us into a deep freeze, where glaciers taller than modern skyscrapers completely buried what is now New York City. It dropped sea levels so incredibly low that ancient humans could literally walk across newly formed land bridges from Asia to America.
All right, Section 3. The Moon's secret habitable past. A brief window for life.
And this brilliantly illustrates our next point. When we look up at the moon today, we just see this dead, barren rock. But it absolutely wasn't always that way. 3.5 billion years ago, the moon would have been a glowing, violent hellscape. Giant magma eruptions created vast seas of lava all across the lunar surface, producing an estimated 200,000 trillion cubic feet of the stuff. Just imagine standing on Earth back then and looking up into the night sky. You would literally see the fiery glow from individual lava flows gushing out of lunar fissures at a rate of roughly 3 billion cubic feet every single year.
But here's the thing, volcanoes don't just erupt lava, they release immense amounts of gas. And these ancient eruptions outgassed so vigorously that they actually gave the moon an atmosphere 1.5 times denser than Mars has today. This atmosphere trapped warmth, preventing water vapor from freezing and allowing liquid water to actually pool right there on the lunar surface. So it is a shocking, mind-bending plausibility that for a brief window of time about 3 billion years ago, right around when life was starting on Earth, the warm and wet lunar environment could have been entirely habitable.
Which brings us to Section 4, the impact that saved Earth, the greatest catastrophe we ever needed.
Speaking of the moon, we really have to talk about how it got there in the first place. Let's rewind the clock 4.5 billion years to a time when the solar system was purely wild and chaotic, and Earth didn't even have a moon yet. So an infant planet named Theia was on a direct collision course with early Earth, and when they hit, it was monstrous. The planets literally broke apart, throwing over a billion tons of debris out into space, which eventually coalesced to form our moon. But the true miracle happened deep inside. Giant slabs of Theia, including its massive iron core, sank down and merged directly with Earth's core. This single event gave us a supercharged, long-lasting magnetic field. So while it sounds like an utter disaster, it was actually a 1 in a million lucky strike that was quite literally the best thing that ever happened to us. To see exactly why it was so great, just compare Earth to Mars. Mars formed where materials were scarce, making it about 10 times smaller than Earth. Because it totally lacked our extra mass, its core just cooled off 4 billion years ago, entirely shutting down its magnetic field. And without that protective shield, violent solar winds stripped away the Martian atmosphere, leaving behind a barren desert. But because of Theia's extra iron from that cosmic collision, Earth's massive core stayed active and molten. It's still continuously generating a strong magnetic shield that protects the thick, life-sustaining atmosphere we are breathing right now.
Finally, Section 5, Alien Life on Titan, the cold, dark possibilities of Saturn's moons. From that fiery creation story, let's venture out into the freezing depths of our solar system. If we look over at Saturn's system, we find evidence of a violently destructive game of cosmic pinball that scattered objects absolutely everywhere. Yet somehow Titan holds a staggering 96% of all the orbital mass there. During that ancient solar system upheaval, countless smaller moons collided and were just destroyed. But Titan? It survived the absolute carnage and actually gorged on the resulting debris, growing so incredibly large that it became one of the only moons with enough gravity to hold onto a thick, dense atmosphere.
When the Huygens probe finally plunged through Titan's dense, impenetrable gloom, the images it sent back to us were just mind-blowing. It revealed actual mountains, rivers, and rain. But at 290 degrees below zero, that rain sure isn't water. It's liquid methane. As one scientist beautifully put it, it looks as if every oil well and gas station on Earth just started leaking all over the place.
Now, obviously, Earth's water-based cells would instantly freeze and die in this unrelenting cold. But telescopes found something truly remarkable in Titan's atmosphere, a chemical called vinyl cyanide. Basically, when sunlight hits Titan's atmosphere, molecules break apart and reassemble, sort of like Lego blocks. And vinyl cyanide is the exact kind of molecular chain that could theoretically build cold-resistant cell membranes for alien methane-based life.
And Titan isn't just lightly sprinkled with this stuff. There are an estimated 10 billion tons of vinyl cyanide sitting in just one of Titan's lakes. It's a completely staggering volume of biological building blocks. Just to put that into perspective for you, if you wanted to build alien creatures out of it, you could literally make billions of giant alien squids from that one lake alone. No joke.
Which leaves us with a truly profound final thought to wrap up this explainer. If unimaginable violence, extreme collisions, and pure cosmic chance created us here on Earth, what truly alien life is waiting for us